Good day everyone. Welcome to the lecture series on power electronics. In this session I will give you brief introduction to DC-DC converter and syllabus that we are going to cover in unit number 3. So that is DC-DC converters. So firstly let us see a few applications of DC-DC converter so that we will know why we need to study DC-DC converters. Okay, once you understand the applications, mostly you will appreciate this chapter. One of the important application of DC-DC converter is as follows. So that is integrated circuits or microprocessors. Usually 12 volts battery is available with respect to these applications. That is integrated circuits or microprocessors. Usually integrated circuits or microprocessor, they require different level of DC voltages like 15 volts, 5 volts, 3.3 volts and 1.5 volts respectively. And you can see clearly that there is a mismatch between source availability and load requirement, and this gap can be addressed by DC-DC converter. So the role of this DC-DC converter is to step down or step up this voltage so as to meet the load requirement. For example, if load requires 15 volts, yeah, you can use a step up converter or boost converter to step up the voltage from 12 volts to 15 volts. Similarly, for example, you want 1.5 volts, then you need to step down the voltage using the buck converter. Okay, so this is one of the important application with respect to the integrated circuits and microprocessors. The next one, DC motor application. Usually whenever we want to control a DC motor, so the source available for DC motor speed control usually battery. Okay, we use battery to supply the power, especially if you go for maybe electric vehicles where battery is the major source and you need to control the speed of the motor. Then how can you control speed of the motor? So speed of DC motor can be controlled by controlling the supply voltage. We know that DC motor will have armature circuit and the field circuit, right? So by controlling field terminal voltage or by controlling the armature terminal voltage, one can control the speed. Okay, and if you look at the battery voltage is fixed. So how can you obtain this variable DC from this fixed DC? Again, using the DC-DC converter. So using control circuit, one can control the voltage, output voltage of DC-DC converter at required level so as to control the speed of the motor. Okay, so this is also one of the important application. And one more application, so usually we know PV sources or so emerging renewable energy sources. Okay, so they are, due to their various advantages, like they are pollution free and they are available in abundant in nature. So this is one of the major source. But what is the problem? Usually source, the voltage or power available at this PV source is DC usually, where loads, most of the loads in power system, so usually they are AC loads. So what are they? Like single phase induction motor, 3-phase induction motor or lights. So those are AC loads. So again you can see that there is a mismatch between source and the load. So source side we have DC power available and load side we require AC. And AC at required level. So maybe for single phase it is 230 volts and for 3-phase you may require at different levels. For example, for domestic level you may require 400 volts, but industrial level you require higher voltages, 3.3 kilovolts or 11 kilovolts and so on. So how can you bridge the gap between these two, source and load? Again, using a two-stage converter, power electron converters. In first stage, DC-DC converter to step up the voltage. Usually here voltage available at PV source, usually that is at low level. So you have to step down in the first stage and then you have to invert it. Using inverter, you have to convert that into AC to make sure that the power available is compatible with the loads, right? So we use a two-stage converter. So this is one of the popular circuit topology that is used in renewable energy source application, especially PV source, right? So this way DC-DC converters are very, very important. You can see the necessity of DC-DC converters. So what is the necessity? So it bridges mismatch between power supply availability and load requirement. especially for these examples that are quoted in this particular slide. It also perform DC transformer action. You can see that transformers, usually we know transformer can step up or step down the voltage. Usually in AC systems, whenever you want to step down the voltage or step up the voltage, we use transformers. But DC, so DC transformers are not available. So that particular problem can be addressed by DC-DC converter. So DC-DC converter action that is similar to that of the transformer action. So you can also refer DC-DC converter as DC transformer. Okay. So DC-DC converters, so due to evolution in the power electronics and due to evolution in the renewable energy sources, so DC-DC and also due to emerging technologies with respect to electric vehicles, DC-DC converters are gaining popularity nowadays. So it is very, very important to learn DC-DC converters. And in this course, we limit our discussion to a basic level DC-DC converters. Okay, I will tell you what is the syllabus that is going to be covered in this chapter. So chapter number 3 or unit number 3. So firstly, we shall see in first lecture we shall see volt second and ampere second balance. So this volt second and ampere second balance is very, very important to obtain the relation between output voltage and the input voltage, output current and input current respectively. Okay. The next in next class we shall see buck converter analysis, a steady state with, including the waveforms. Okay, I will also explain with by considering waveforms also. And of course our focus would be on steady state analysis of buck converter. So buck converter is a step down converter. So output voltage is less than input voltage, then the converter is known as buck converter. Okay. So in first with respect to this buck converter analysis, in first lecture we shall see power circuit of buck converter. Okay, we shall see the realization of buck converter, and then we shall see a relation between duty ratio and average output voltage, followed by voltage ripple and current ripple mathematical expression in continuous current mode and discontinuous current mode respectively. You can see here I have mentioned CCM and DCM. So CCM is corresponding to continuous current mode and DCM is corresponding to discontinuous current mode. I will explain what is this CCM and DCM in next class. Okay, while discussing the buck push converter, I hope you will understand what I mean by continuous current mode and discontinuous current mode respectively. Nextly we shall see boost converter analysis including the required waveforms in both cases. So that is case 1 continuous current mode and case 2 discontinuous current mode. In both cases we shall see what is the power circuit and then what is the relation between output voltage and input voltage and duty ratio, voltage ripple and current ripple. Now nextly we shall see the steady state analysis of buck push converter. Buck push converter is a converter which can step up or step down the voltage. Okay, output voltage may be more than input voltage or less than input voltage. Okay, so where in case of boost converter it can step up the voltage. Boosting means it is stepping up. Output voltage would be more than the input voltage, then that circuit, that the particular converter is known as boost converter. Buck push converter, so output voltage either based on the duty ratio. I will tell you what is duty ratio in next class. So based on the duty ratio, output voltage can be more than input voltage or less than input voltage. So that converter is known as buck push converter, and we shall see the power circuit of buck push converter, relation between duty ratio and average output voltage, voltage ripple and current ripple respectively. Okay, this is syllabus that I am going to cover, and lastly we shall also see the introduction to isolated DC-DC converters. Mostly I will be sharing NPTEL lectures by Professor Umanand in order to cover the syllabus with respect to isolated DC-DC converter. Okay, so please go through them. Okay, yeah, this is the syllabus. So thank you. In next class we shall see the power circuit of buck converter. Thank you.